Hi everybody, and thank you for joining today's live lesson. Today's live lesson's topic is the cubes method. The cubes method is a way to simplify solving math word problems. Now, we've all had to solve word problems. A train has 27 cars. It travels 75 miles at 50 miles an hour. It makes 4 stops. The next day, the same train travels 32 miles and makes 2 stops hauling 19 cars. How many miles did the train travel in all in the 2 days? What? Word problems can be very confusing. Sometimes there's more numbers in the word problem than what we actually need to solve the question. And where is the question hidden in that word problem anyway? A lot of times there's a lot more information that's given than what we actually need to solve the question that's being asked. So if we want to make solving word problems easier, we need to remember cubes. C-U-B-E-S. Cubes. C stands for circle. We're going to circle the important numbers in our word problem. U stands for underline. We're going to underline the question. B is box. We're going to box the important math action words. E stands for eliminate. We're going to get rid of any information in that problem that isn't actually helping us solve the question that we've underlined. And S stands for select our thinking pattern and solve. So to select our thinking pattern, we're going to go back to our boxed action words to find out, are we going to add or subtract, or are we going to do both? And then we're going to solve it. We're going to use the math skills we already know to solve the problem. So let's check out this word problem. Kayla has $11.53. Her grandma gives her $3 and a bike helmet for her birthday, and her pop-up gives her $3 more. How much money does she have now in all? So first we're going to remember C. C stands for circle the important numbers. So we're going to look and we're seeing that all the numbers in this word problem are dealing with money. Kayla has $11.53. Her grandma gives her $3 and a bike helmet for her birthday, and her pop-up gives her $3 more. How much money does she have now in all? So we're going to circle all of those, and then we can come back and double check and make sure they all are important after we find the question and underline it. And that comes next. U for underline. Underline what the problem is asking. So Kayla has $11.53. Her grandma gives her $3 and a bike helmet for her birthday, and her pop-up gives her $3 more. How much money does she have now in all? Does anybody see the question being asked in this word problem? Good, good, right. How much money does she have now in all? So we're going to underline that question because that is what we're actually going to find the answer to. How much money does she have now in all? Next is B. We're going to box the math action words. Let's review really quick the action words that we've already talked about. If we see words like add, together, combine, increase, total, join, all together, in all, plus, both, sum, we know we're adding. We're using addition. If we see words and phrases like how many more, how much more, left, decrease, take away, minus, difference, less than, remains, greater than, subtract, is left, fewer than, or ER words like longer, shorter, taller, smaller, those are all words that are telling us that we're going to use subtraction. We're going to subtract. And that should be in your files that we've talked about in previous lessons if you need to go back and look at it again. So we're going to box the math action words. So let's look at the problem. Kayla has $11.53. Her grandma gives her $3 and a bike helmet for her birthday, and her pop-up gives her $3 more. How much money does she have now in all? Does anybody see any of those math action words? Good, in all. So we're going to box in all, and that is going to show us how we're going to solve the problem later. But next we need to eliminate. Eliminate unimportant information. Kayla has $11.53. Her grandma gives her $3 and a bike helmet for her birthday, and her pop-up gives her $3 more. How much money does she have now in all? So we're looking for how much money does she have in all? That is the underlined question. What information in this word problem don't we need to find that out? Good, I'm seeing some good answers. Good, a bike helmet. It doesn't matter for this problem that she got a bike helmet. It's nice that she got a bike helmet for her birthday, but we're interested in how much money she has. So we can cross off the bike helmet. So far we have C, circled the important numbers, U, underlined the question, B, boxed the action word, and E, eliminated unimportant information. The last thing we need to do is select our thinking pattern and solve, S. So we're going to go to select our thinking pattern. We're going to go back to the box words, in all. And we said if we see those math action words in all, that's telling us that we need to do what? Good, add. In all means that we add. So we're going to add these numbers together. So next we need to solve the problem. And to solve the problem, we're going to add all three of these numbers. We're going to start off by adding $11.53 to $3. We're going to set up our problem, make sure that our decimal points are lined up, make sure that we start at the right-hand side. We need the decimal points lined up, so we make sure that we're adding the right numbers together. So 3 plus 0 is equal to, good, 3. And then 5 plus 0, because we moved to the left, 5 plus 0 is 5. Now we have 1 plus 3 is 4. And 1 plus, there's not a number there. Well, if there's not a number there, if there's not a number in the tens column, that's a 0. So 1 plus 0 is, good, 1. And we need to remember that we're talking about money, so we need to add our decimal point and our dollar sign. So next we have the second $3 to add to the total of the $11.53 plus the first $3. Now we have another $3 to add. So we're going to set up our problem. We're going to make sure that our numbers align correctly, that our decimal points align. So we're adding all the correct numbers together. Starting at the right, 3 plus 0 is, good, 3. And 5 plus 0 is 5. 4 plus 3 is 7. Good job. And then 1 and, oh, there's not a number there, so we treat that as a 0. 1 plus 0 is, good, 1. And because we're dealing with money, we need our dollar sign and decimal point. Good job, guys. So we have our dollar sign and our decimal point. So our answer is Kayla has $17.53 in all. If we add the $11.53 plus the $3 plus $3, we get $17.53. But we still need to check our work. It's always important to check your work. And when we check our work, we use the opposite math function that we use to solve the problem. So we used addition to solve the problem. What is the opposite math function of addition? Good, subtraction. When we're adding, we're grouping things together to combine them into one. When we are subtracting, we are taking a whole and we're separating it apart. So to check our answer and to use the opposite functions, we're going to start with our answer that we had from our addition problem, and then we're going to subtract the $3 that we added to it. So we're starting with our total, and we're going to subtract that $3 that pop-up gave her. And we're going to set up our math problem the same way as we set up the addition. We have to make sure our decimal points line up, and we're going to start at the right. And 3 subtract 0 is 3. And 5 subtract 0 is 5. Good. And then 7 minus 3 is 4. And 1 subtract, oh, there's not a number there. So we're going to treat that as a 0. Good. So 1 minus 0 is 1. We're talking about money, so we need our $sign and decimal point. Good job. Now we have another $3 to subtract. So now we're going to subtract the $3 that Grandma gave her. So set up our problem. Again, we make sure our decimal points are lined up, so we're subtracting the right numbers from the right numbers. We're going to start over on the right-hand side like we always do for math. 3 minus 0 is 3. 5 minus 0 is 5. 4 minus 3 is 1. And 1 minus, there's not a number, so it's a 0. Good. 1 minus 0 is 1. And again, money, so we need our $sign and decimal point. And now to check to see if we got it right, we look at the original number we started with over here, and does that match our answer over here? Yes, they match, so you got it right. Good job when you checked your work. So when we're solving word problems, we need to remember the cubes strategy. We're going to circle the important numbers, underline the question that's being asked in the word problem. We're going to box the important math action words. We're going to eliminate any information in the problem that doesn't have to do with what the underlined question is asking us. And then S, we're going to select our thinking pattern. Are we adding? Are we subtracting? Are we doing both? What are we doing? That boxed keywords are going to help us figure that out. And then we are going to use our math skills to solve the problem. So now can you do it? A train has 27 cars. It travels 75 miles at 50 miles an hour. It makes 4 stops. The next day, the same train travels 32 miles and makes 2 stops, hauling 19 cars. How many miles did the train travel in all in the 2 days? If you can solve this problem using the cubes method and post your answer along with your cubes work, don't forget that too, on my message board, you can earn some participation points. If you want some more cubes fun, check out this website because it's a fun cubes song that's going to help you remember what the C, circle, U, underline, B, box, E, eliminate, and S, select your thinking pattern, and solve stand for.